Let's understand force and Newton's laws of motion in this video. Have you ever wondered why a football starts rolling when you kick it? Or why a book stays still on a table? These everyday moments are all about force. And today, we will see how force changes motion, speed, direction, or shape. A force is simply a push or a pull. For example, kicking a ball from rest makes it move. Pushing a trolley can make it go faster, and using brakes makes it slow down. A cricket bat changes the ball's direction, and squeezing a lemon changes its shape. Force is a physical quantity, so we must say how strong it is and which way it acts. The SI unit of force is the Newton, written as N, and 1 Newton is the force that gives 1 kilogram an acceleration of 1 meter per second squared. We often measure force with a spring balance, the same kind used earlier to measure weight. When you pull the balance, it shows how strong your pull is in newtons. Scientists can measure very tiny forces, down to a millionth or even smaller. But a light touch is about 1,000th of a newton. In most cases, more than one force acts on an object at the same time. When two forces are equal and opposite, they are balanced, and the net force is zero. Think of a tug of war, where both teams pull equally. The rope does not move. But if one team pulls harder, the forces are unbalanced, and the rope moves toward the stronger team. If two forces act in the same direction, add them to find the net force. If they act in opposite directions, take the difference and keep the direction of the larger force. For example, two forces of 10N and 6N acting to the right give a net force of 16N to the right. If 10N right and 6N left act, the net force is 4N to the right, and if reversed, it is 4N to the left. Sometimes forces act at angles or at different ends of an object and may cause rotation instead of straight motion. Friction is an important force that acts opposite to motion between surfaces that touch. Rough surfaces give more friction, and smooth surfaces give less. So a smoother floor makes a box slide more easily. A block moves only when the applied force is larger than friction, and when it moves at constant speed, the forces balance and net force is zero. Galileo told us that no force is needed to keep an object moving steadily if there is no resistance. Newton built on that and introduced inertia, the idea that objects resist changes in their motion. Newton's first law says, an object at rest stays at rest, and an object in motion keeps moving with constant velocity, unless a net force acts on it. In graphs, an object at rest has a flat position timeline and zero velocity, while constant velocity gives a sloped position timeline and a flat non-zero velocity timeline. Newton's second law connects net force and acceleration. A equals F by m or F equals ma. This means acceleration is proportional to net force and inversely proportional to mass. For gravity near Earth, the force is F equals mg, with g about 9.8 meters minus 2, often taken as 10 meters minus 2 for quick work. For example, holding a 100-gram mass feels like about 1 Newton of upward force from your palm. Real examples: catching a ball gently, airbags in cars, and pulling hands back while catching reduce force and prevent injury. A weightlifter holding a 30-kilogram barbell must apply about 294 newtons upward using g equal to 9.8 meters seconds minus 2. A student pushing a 25-kilogram block where friction is 50 newtons will not move it if they push with 50 newtons, but pushing with 55 newtons gives net 5 newtons, acceleration 0.2 meters second minus 2, and a displacement of 0.4 meters in 2 seconds. A sports car example shows how acceleration and force change over time. If acceleration is 2 mrs minus 2 for 1500 kg, force is 3000 newtons to the east, and if acceleration is negative, force acts to the west. Newton's third law tells us forces come in pairs. If object A pushes B, then B pushes A equally and oppositely. Kicking a ball, the ball pushes your foot back. When you walk, your foot pushes the ground and the ground pushes you forward. These action and reaction forces act on different objects, so they do not cancel each other. For example, Earth pulls a falling fruit, and the fruit pulls Earth equally. But Earth hardly moves because its mass is huge. A bullet fired from a gun feels the same force as the gun, but the bullet's acceleration is much larger because its mass is small. When objects are linked, we can treat them as one system and ignore internal forces like tension using A equals F divided by the total mass to find the system acceleration. So, what do we learn from this? We learn that force changes motion, and the net force decides if an object starts, stops, or speeds up, with the rules given by Newton's 3 laws. Let us quickly remember, force is a push or pull measured in newtons. Balanced forces give no change. Unbalanced forces give acceleration. And action and reaction always occur in pairs. Keep exploring examples around you. Try small experiments safely and ask why things move the way they do. Thanks for listening. And if you want to learn more, do explore similar lessons on EduRev to build your confidence step by step.